Welcome to the Penny Drop Investigation. For those of you who cannot be in my classroom, I've had to come up with a way to adapt how you experience investigations throughout this 7th grade course. So, instead of you coming into my classroom in order to experience the labs, I will be doing them in my at-home laboratory. You will be watching me collect the data, but you will still be doing all of the parts to the lab that are required for any of my other students. So for this first lab, this is the investigation we use for the scientific method. It goes through all the parts to the scientific method, and it additionally looks at the factors that affect the cohesion of water on a penny. This is the problem that we're going to investigate for this lab. As I go through the lab, you need to fill in the information on your Penny Drop Investigation worksheet, which you can download from the assignment that you just opened up. Let's start with the independent and dependent variables and the control. Again, our problem to investigate is what factors affect the cohesion of water on a penny. In order to understand that, you need to know what cohesion is. Cohesion is sometimes known as surface tension. Surface tension is what allows water molecules to stick to each other. And when you see this in the collection of data part of the lab, you'll see that the water or the other liquid that we choose to use forms a bubble on top of the penny. And we're looking at the factors that might affect how many drops of water we can fit on the surface of a coin. So let's move right into the lab. Filling these things in on your worksheet, we're going to start with the variables and the control. Remember, we need to do these before we can do the hypothesis. The independent variable in this lab, it's got to be something other than water, because we're going to use this to compare to the cohesion of water. So for this lab, I've chosen to use hand soap. What we're comparing hand soap to, otherwise known as our control group, is water. And the dependent variable for this lab is going to be the number of drops that fit on the penny. So we'll be testing hand soap and we'll be testing water. Before we go too much further into this, let me point you down to the bottom of the lab. If you scroll all the way down to the last page, you'll see the grading rubric for this lab. Each part of the lab is worth a maximum of 15 points. We have the hypothesis, the procedure, the data table, and the graph. You see there is one more category called the conclusion, but we're going to save this part for the next assignment associated with this lab. So what you need to turn in on your worksheet would be these first 4 things: the hypothesis, the procedure, the data table, and your graph. Let's go back to the hypothesis. We know that a hypothesis uses an if-then-because statement. And if you remember from our last assignment, the if goes with the independent variable. This is why we picked out our independent variables first. So we can put if hand soap is used. In this case, we don't want to say increase or decrease. This particular lab isn't looking at a cause and effect relationship where if you increase one factor, it changes another factor. In this particular case, we're just simply looking at if we use one category or if we use one item instead of another item. If hand soap is used, the next term would be then, the, and here's where you put in the dependent variable. The number of drops on the penny will, and in this particular point, you need to choose increase or decrease. Do you think there will be more drops of hand soap that fit on the penny or more drops of water? I'm going to let you choose that, so I'm going to put increase or decrease in parentheses for this part of the hypothesis, but you need to choose one of those 2 terms based on whatever you think will happen. This is your prediction. So if hand soap is used, then the number of drops on the penny will increase or decrease because, and here's where you put in your scientific reason for why you chose what you chose. Remember, Whenever you're doing the because portion of the hypothesis, you cannot use the factors or the independent and dependent variables in your response. It would not be correct to say if hand soap is used, then the number of drops on the penny will increase because hand soap was used. That's like saying the cat is orange because it's orange. It doesn't actually give a reason. So make sure when you're thinking about what you think will happen, make sure you have some sort of scientific basis for your hypothesis. I'll let you finish filling in the rest of those, and then we're moving on to the procedure. Remember, the procedure includes both the materials and the step-by-step directions. As you'll see in our next step, in the next video you watch, here's where I will take you through the procedure. Make sure that you're writing down exactly what you think will, or exactly what you see happening. If you need to stop the video at any time to do that, that's probably in your best interest. And then we will come back to a separate video on the results that we get and analyzing the data using a graph.